Okay, so today in class we talked about the standard normal distribution and just the normal distribution and how you can have situations where if you know the mean and you know the size of one standard deviation, which in this particular example here would be 3, from here to here is 3, then you can figure out how your data should be distributed, what percent you would expect to be right here near the middle. Remember that these two sections add up together to 68. And then you've got 13.5 over here, and over here it's all symmetric. And then remember these two add up to 2.5. Okay, so one of the problems we did was this one. And we had a mean of 81. Let me get my pen here. So a mean of 81 and a standard deviation of 7. And so we said that means the 81 goes right here, and then this one would be 88, and this would be 95, and this would be 102. So going to the right, here's the mean, and then I add 7, add 7, add 7, because that's the standard deviation. So going to the left, I'm going to subtract 7. So 74 and 67 and 60 are what these vertical lines here and here and here correspond to. So we already know the percentages, okay? And again, this is really handy for if I want to answer questions like what percent of students, and this was scores on a test, so what percent of students scored below an 88? So below an 88 would be me coming right here and saying I want everybody, that's not the color I wanted though, here we go. Everybody from here down to my left. So let's make this a little bigger. This whole part right here. That would be the percent of students scoring less than or equal to 88. Okay, and that percent would be, remember we have let's go with a different color so you can see it. 13.5, 34, let's use the percentage sign. I'll just delete the other one. And that's all right. That's right. Okay, so this one's going away. This one I'm going to copy because I have two of those here and here, then here and here, and way out here. So this would really be 68%, which is all that middle area, plus 16, which 13.5 plus 2.35 plus 0.15. These two add up to 2.5. 2.5 plus 13.5 is 16. And then I have plus 68. So altogether, that is 84%. I don't know why I'm not happy with that answer, but I guess that's, let's see. Maybe it's time to get out my calculator, huh? I'm thinking 81.5. So I'm not sure if I am, nope, 84 is correct. So this is all 84%. So again, that would be the answer to the question, what percent of students scored less than 88? Okay, all that is what we've already done. I just wanted to give you perspective for what this last little bit of the piece, small piece of the puzzle is. And that is, what if we went back here to this question, and now there's a new problem. What percent of students made an A? All right, if I go to my picture here, well, an A is 90 or higher, and that's not one of these numbers. So the ones we did in class conveniently asked us about the same numbers that were exactly 1 standard deviation away from the mean, or 2 standard deviations away from the mean, or 3 standard deviations away from the mean. It asked us about the numbers that were easy to find. But sometimes you're asked about a number that's not as easy to see. Like what percent of kids made an A? So an A means higher than 90. So we're talking somewhere over here now. Okay, so we're trying to figure out what percent of students would be, let's go with that, and make it a little smaller in this area right here. Okay, if the number you're asking about is not right there on one of those standard deviation marks, if it's not 1 standard deviation away from the mean, or 2, a whole number of standard deviations away from the mean, then you're going to have to use what's called a z-score. Okay, and here's the little notes page for a z-score. Okay, this is to find more precise things in between those sort of boundary lines for the percentages. The z-score for any data point is found by, here's a formula you have to use. The x stands for your number we're asking about. So in this case, it would be 90. X bar still means the mean. And sigma, this little symbol right here, means however the size of a standard deviation. It means 1 standard deviation, or the width of a standard deviation. Okay, once you find the z-score for a certain number, the standard to normal table shows what percentage of the data is expected to be below or to the left of that number. So in other words, what I'm going to do here is, if I want to know about 90, okay, let's say here's 90. Then what I have to do is I have to turn 90 into a z-score. Really what you can think of a z-score as is, this is not exactly 1 standard deviation above the mean or 2 standard deviations above the mean. I have to figure out how many standard deviations above the mean it is. Maybe 1.3, maybe 1.4, maybe 1.2. It's somewhere in that. So that's what I have to figure out with the z-score formula. So the z-score formula, let's do this right here, says I take my number and I subtract, that's a subtraction symbol. So I subtract the mean. So in other words, I'm looking at how far above 81 is 90. Then I'm going to divide that by the size of a standard deviation, which for this problem was 7. Let me just find a little division bar here. And that's the formula for my z-score. And we would just say z equals that. And I might want to put a space there. Okay, so in my calculator, I'm going to do 90 minus 81, and that gives me 9. Divide that by 7, and my answer is 1.285. That's what I get, is 1.285. So in other words, 90 is 1.285. Here's 1 standard deviation. From here to here is 1.285 standard deviations above the mean. So notice, if your z-score is positive, that means the number you're looking at is above the mean. If your number was below the mean, you would expect your z-score to be negative. Now the z-score table, which is what we have to use with this, really, at this point at least, goes by tenths. So I'm going to round that. Okay, I'm going to round that to 1.3. And then I go down to this table. This is the z-score table. It is in your textbook, the green textbook, on page 248. Okay, so my z-score is 1.3, so I'm going to go to 1, and then I go out to 0.3. So where those two things intersect, right in here, this is the number I'm looking at, and it says 0.9032. I know it's kind of hard because of the highlighting I've put on there to see, but that's what that says, is 0.9032. Let's get rid of everything and you can see it better. There it is. So what this is saying is that 0.9032 is the probability that a student scores to the left of that. Okay, the z-score table only tells you about to the left. So that's like a 90, what was it, 0.9032? Yep, 90.32% chance that if I randomly select a student, they made less than a 90. So if we're being asked about greater than, we have to subtract from 100%, or subtract from 1 if it's still in decimal form. Oops, that was an unintentional. So 1 minus 0.9032 is what I'm going to do. Surely this thing has a calculator. Okay, so 1 minus 0.9032. That gives me 0.0968. Okay, so that means the probability of someone scoring above a 90 is 0.0968. Or another way of thinking of it is 9.68, almost 10%, 9.68% of students made an A. And that answers my question. So again, if the number you're looking for does not fall neatly into these numbers that we get from the standard deviation, you have to use this formula and then take whatever number you get, go to this table, and this table will tell you the probability of everything to the left of your number. So if we're talking about less than, you look at this and you say, yep, that's my answer. If you're talking about greater than would be to the right of. So you would have to subtract this number from 1. And that should pretty much tie up everything you need to know in order to do your homework very well.